In this video, we're going to be working our problems backwards. We're still dealing with ellipses, but we're going to be writing the equations instead of graphing them and pulling information from the equations. So the standard forms of the equation of an ellipse, reminder, if you have a horizontal ellipse, it's going to be x minus h squared over a squared. That's the biggest thing, is your a is going to be under the h value. Y minus k squared over b squared is equal to 1. Now, if it is a vertical ellipse, it's going to be right opposite with the a's and b's. It's going to be x minus h squared over b squared, and reminder that a is always bigger than b, plus y minus k squared over a squared equals 1. So a vertical is the larger number is going to be under the y. So blank is the distance from the center to the vertices. That's going to be positive and negative a to the vertices and positive and negative b to the co-vertices. To find c, or positive negative c, you can put it either way, which is the distance to the foci, we're going to use the formula. C squared is equal to a squared minus b squared. So let's write the equation. Given a graph, let's write the equation of this ellipse. So the center of the ellipse is right here. You can actually draw the major axis and the minor axis if you would like to. And there those are. So the center is located right here at, looks like -1, -1, +2. The co-vertices looks like, or excuse me, the co-vertices are up and down 3. The actual vertices, you can count boxes, 1, 2, 3, 4, 5, 6, 7, and 7 is the distance to your vertices there. So from -1, 2, let's go right 7 and left 7. So that's going to be at -8, 2, and at 6, 2. There's going to be your vertices. We go up 3 and down 3. That's going to be at -1, 5, and -1, -1. There are your co-vertices. So your equation is going to be this. The 7 and 3 is what's going to be important. You have, first off, the center has been translated. Left 1 and up 2. So that's going to be x plus 1 squared and y minus 2 squared. That's the first thing I would do. It's a horizontal ellipse because it's longer horizontally. So therefore, your a squared is going to go under the x stuff. Your b squared is going to go under the y stuff. And there is your equation. To find the foci, again, you're simply going to do c squared equals a squared minus b squared. So c squared would equal 40. So therefore, c is equal to the square root of 40, which is somewhere around 6.3. So therefore, we're going to go right and left 6.3 from our center. So your foci is going to be located at 5.32 and -7.32. Okay, number 2. First off, let's find our center, which it looks to be located about right there at 3, -2. And again, from just that alone, you can go ahead and you can start your equation. It's going to be x minus 3 squared and a y plus 2 squared. There's your transformations. This is going to be a vertical ellipse, so we need an a and a b value. So your a value would be the distance from here to here. Your b value would be the distance from here to here, which is going to be 5 and 2. So since it's vertical, your larger number goes under the y. So there's your a squared, there's your b squared, and it's equal to 1. There's your equation. So again, your vertices are located above and below the vertex. So we're going to go up 5 and down 5. So that's going to be located at 3, 3, and at 3, -7. Your co-vertices are located to the right and left of the center. So that's going to be located 2 units to the right, which is at 5, -2, and 1, -2, 2 units to the left. To find your foci, you're going to do c squared is equal to a squared minus b squared, which is 21. So your c value there is going to be the square root of 21, which is somewhere around 4.6. And that would be positive and negative. So we're going to go up and down 4.6 from our center. So our foci is going to be located at 3, 2.6, and 3, -6.6. The next one, here's the center, which is located at 1, 2, 3, 4, 5, 0, 5. Whoops, center goes here. But we can go ahead and do half of our equation here. So our x value is not going to get shifted any, so I didn't need parentheses there. It's going to be plain x squared. We're going to have y minus 5 squared, and the equal 1, we can go ahead and put it. Here is our co-vertex, the distance to our co-vertex. Here is the distance to our vertex, which is 10 and 1. Since it's a horizontal, then a squared is going to go under the x, b squared is going to go under the y, and you can put that 1 or you don't have to. Either way is fine. Your vertices are going to be located right 10 and left 10, so you could actually just do plus and minus 10, comma 5. Your co-vertices are up 1 and down 1, which is located at 0, 4 and 0, 6. C squared is equal to a squared minus b squared, which is 99 in this case. So therefore, C is going to be the square root of 99, which is about 9.9. So therefore, we're going to go right 9.9 and left 9.9. So our foci are going to be located at positive and negative 9.9, comma 5. Okay, next up, what if we're given characteristics? Here's what we're going to do. Find the center, and we might have to use our midpoint formula to do so, along with our vertices, our co-vertices, or our foci. Remember that there's a lot of symmetry here. The center is the middle of the two vertices, it's the middle of the two co-vertices, and it's the middle of the two foci, so our midpoint formula. Then we're going to use our vertices to find A, the co-vertices to find B, and if we need it, we're going to use this formula to find our C, or to find missing parts using C. Then we're going to determine the direction and write the equation. So first off, we have a length of a major axis. We have vertices here and here. So let's go ahead and find out, is it going to be a vertical or is it going to be a horizontal? So if our vertices are located at 5, negative 2, which is somewhere right in here, and at negative 19, negative 2, which is somewhere right in here, that's going to be a horizontal ellipse. So therefore, we're going to have, let's go ahead and write this, x stuff squared over a squared plus y stuff squared over b squared is equal to 1. To find the center is going to be the center of these 2 points. Okay, the middle of our 2 vertices is the center of the ellipse. So to find that center, we're going to use our midpoint formula. The midpoint formula says take your x's, add them, and divide by 2. Take your y's, add them, and divide by 2. So the center of this ellipse is going to be located at negative 7, negative 2. So therefore, we can put our center right here, x plus 7 squared, y plus 2 squared. Okay, the length of our major axis, or excuse me, length of our minor axis, this is the length of our major axis, is the distance from here over to here. So we can use that. We can use this distance to find that, or we can say, how far is it from the center to either one of these vertices? That's the A value. The distance from a center to a vertex is the value of A. So from here to here, or to the other one, that's a distance of 12. So my A value is 12. The whole minor axis has a length of 10. Your B value is from the middle to the outside, not the length of the whole thing, but the length of half of it. So there's your B value. So since this is a horizontal, your larger number goes under x, so that's going to be x stuff over a squared, and then your y stuff over b squared. So there's your equation. Okay, co-vertices. First step, let's go ahead and find our center. The center, we're going to use the midpoint formula. Add your x's, and again, you can use your co-vertices, you can use your vertices, or your foci. The center is the middle of any of those. Add your x's, divide by 2. Add your y's, divide by 2. So therefore, the center is located at 3, 1. So let's go ahead and start our equation. X minus 3 squared over stuff, y minus 1 squared over stuff is equal to 1. So there's half my equation. Now I need to find my A values and my B values. The B value is the distance from the center to a co-vertex. So therefore, my B value here would be 6. Your A value is the distance from the center to a vertex. Now, they give you the length of the major axis. And again, the major axis is going to be all the way across your ellipse. So therefore, the A value would be half of that major axis. So the next step is, okay, is this going to be a horizontal or vertical? Okay, co-vertices, 9, 1 and negative 3, 1. is going to be like over here and up here. That's your co-vertices. Your co-vertices are horizontal. That means your vertices are going to be vertical. This is going to be a vertical ellipse. So the larger number goes under the y stuff. So your a value squared, 196 goes under y. Your b value squared, 36 goes under the x. So there is your equation. Okay, vertices, and let's go ahead and determine before we even go any further, is this horizontal or vertical? Your vertices are located at 12, -9, so right 12 down 9. Your co-vertices are at -6, -9. Or excuse me, your vertices are at 12, -9 and -6, -9. So since those are straight across left and right from each other, 12, -9 is somewhere over here, -6, -9 is here. So therefore, those are horizontal of each other, and those are your vertices. That means this is a horizontal ellipse. Okay, the next thing, let's go ahead and find our center. To find our center, you can take either your vertices or co-vertices and find the middle. Add your x's, divide by 2. We're going to take these 2 points. Add your x's, divide by 2. Add your y's, divide by 2. That gives you the 0.3, -9. So therefore, your equation is now x minus 3 squared over stuff plus y plus 9 squared over stuff is equal to 1. Now let's find our a and b values. The distance from this vertex to this vertex. Since it's a horizontal line, I can simply look at my 12 and -6 and see that that's a distance of 18. That's the distance all the way across. So that means my a value, which is halfway across, would be 9. Co-vertices, the distance from 3, -7 to 3, -11. Again, all you have to do is worry about how far is it from -7 to -11. That's a distance of 4. That's the distance all the way across, so therefore my b value would be half of that, which is 2. Since this is a horizontal ellipse, my larger number goes under the x. So a squared goes under x, b squared goes under y. Okay, vertices 0, 12, and 0, -18. Those 2 points are above each other. Okay, and since those are the vertices and they're above each other, that means that this is a vertical ellipse. And you can graph that if you have trouble seeing it. The center of this ellipse, to find it, we're going to add our x's, and you can do it for your vertices or co-vertices. Add your x's, divide by 2. Add your y's, divide by 2. So the center is going to be located at 0, -3. So your equation now looks like this. X squared, you don't have to do plus or minus anything. Y plus 3 squared is equal to 1. Okay, vertices. The distance between those vertices, that's called your major axis. The length of your major axis is double A. So therefore, the distance from 12 to -18 is 30. Your major axis has a length of 30, so that means that A is half of that, which is 15. Your minor axis, the distance from 4, -3 to -4, -3. The distance, and you don't have to worry about the -3s, are the same. How far is it from 4 to -4? That's a distance of 8. So therefore, that's the distance all the way across your ellipse. So therefore, your b value would have a length of half of that. Since this is a vertical ellipse, the larger number goes under the y. So therefore, a squared, which is 15 squared, is 225, goes under y. B squared goes under x, and there is your equation. Okay, number 8. Again, let's first determine if it's a horizontal or vertical. Since your vertices are located at 5, 11, and 5, -15, those points are above and below each other, so therefore this would be a vertical. Since your vertices are above and below each other, or you could have done the same thing, the foci has to lie on the major axis. Those two foci are above and below each other, so therefore your major axis is vertical. So that's the first thing we determined. Now let's find our center. To find the center, find the midpoint of any of these. Add your x's, divide by 2. Add your y's, divide by 2. And notice it doesn't matter if you'd use either set of points, you would have got the exact same thing there. The center is located at 5, -2. So therefore, that's going to be x minus 5 squared over stuff. Y plus 2 squared over stuff is equal to 1. Your a value is half of the major axis. So let's find our major axis here. The distance from 11 to negative 15 is 26. So therefore, A would be half of that. Now, you got to be careful. Foci tells you a C distance. Okay? The distance from 5 negative 10 to 5 negative 14 is 24. Your C value will be half of that. So now we need a B value. Here's how you find it. C squared is A squared minus B squared. Your C squared here is 12 times 12, which is 144. Your A squared is 13 times 13, which is 165 or 169. When you solve this, it gives you B squared is 25. So B must be 5. This is a vertical ellipse. The larger number goes under the Y. So therefore, your A squared goes under Y. Your B squared goes under X. Next one. Your vertices are 15, 3 and negative 7, 3. Those are horizontal of each other. Since they're vertices, that's going to be the endpoints of your major axis. So you have a horizontal major axis. The distance between these 2 points is 22. So therefore, your A value would be half of that, which is 11. Your C value, now this one's a little tricky because they give you 4 plus and minus the square root of 21. So let's see if we can figure that out. Your foci, let me kind of graph this out for you, see if it makes more sense. 4 plus root 21, 3, and 4 minus root 21, 3. So let's say that here's 3 on my y-axis, and here's 4 on my x-axis, right there. So plus root 21, that's somewhere around 4 or 5, about 4.5. So you're going to go right 4.5 and left 4.5, and there's your 2 endpoints of your foci. So therefore, how far is it from here to here, or how far is it from here to here? Well, it's this, the root 21. So here, your C value, the distance from here over to here, or the distance from here to here, is simply the square root of 21. That's it. So now let's erase that. I still haven't found my center. I'm kind of doing this one out of order. The center, we can take our 2 vertices, add the x's, divide by 2, add the y's, divide by 2, gives you 4, 3 as a center. So therefore, my equation now is x minus 4 squared over stuff, y minus 3 squared over stuff is equal to 1. I have my A value right here, but I don't have my B value. But I know that C squared is equal to A squared minus B squared. C squared would be 21 is equal to A squared, which is 121 minus B squared. Let's see, let's solve that. That gives you B squared is 100. So B would have to be 10. Since it's a horizontal ellipse, larger number goes under your X. A times A is 121. Smaller number goes under your Y. B times B is 100. So there is your equation. This one gives you co-vertices and the foci. Co-vertices are 0, 6, and negative 6, 6. Those are horizontal. However, those are co-vertices. So that means my vertices would be vertical. This would be a vertical ellipse. Let's find my center. To find the center, you could find the midpoint of any of these. So 0, 6, and negative 6, 6, add your x's, divide by 2, add your y's, divide by 2. So therefore, the center is at negative 3, 6. So that's got my equation started. That's going to be x plus 3 squared over stuff plus y minus 6 squared over stuff equals 1. The distance, now, again, anytime it's written in this form, it makes it a little bit easier. And we'll do that in a second. Let's do our B values first. B value is the distance from the center to a co-vertex. So the center was located here. The distance from there to a co-vertex is going to be a distance of 3. Your C value, that's what I was fixing to get at a while ago. Your C value here, how far is it from the center, which is 6, to each of the foci? Well, this plus and minus tells you that distance. It's going to be 2 root 10. You're going to go right 2 root 10, which is the plus, and then you're going to go left 2 root 10, which would be the minus. Or excuse me, up 2 root 10, which is the plus, and down 2 root 10, which is the minus. So therefore, we know that C squared is A squared minus B squared To square this, we're going to do square each piece. That's 4 times 10, which is 40, is equal to a squared minus 9. So that means that a squared has to be 49, so a is 7. Since it's a vertical, your larger number goes under the y, so a squared, which is 49, goes under y. B squared, which is 9, goes under the x. Number 11. You have co-vertices at -9, -3, and -9, -11. Those are vertical of each other, but those are the co-vertices. So that means your vertices will be horizontal of each other. This is a horizontal ellipse. The center, add your x's, divide by 2. Add your y's, divide by 2. So your center is located at -9, -7. So let's go ahead and start our equation. That'd be x plus 9 squared and a y plus 7 squared equals 1. Now we need a, b's, and c values. Our b value will be half of this distance. The distance from -9, -3 to -9, -11 is 8, so therefore my b value is 4. My c value, again, we can pull from this. -9 is the center, so therefore the distance from there to each foci is located right here. So 4 root 3 is going to be my c value. And I know that c squared, let's go ahead and do this. C squared would be 16 times 3, 48. C squared equals a squared minus b squared. When you solve that, it gives you a squared is 64, so my a value must be 8. Since it's horizontal, my larger a squared value goes under x, and my b squared value goes under y. Number 12. This one's a little bit easier. The length of the minor axis is 8, so that tells me that b is 4, so I can go ahead and pull that from it. The center of this circle, or excuse me, center of the ellipse is, you can use the center of these 2 points, add your x's, divide by 2, add your y's, divide by 2. So the center is located at 8, 0. So therefore, let's go ahead and start. X minus 8 squared plus y squared is equal to 1. Now let's find let's say I've got my b value. I can find my c value. The distance from here to here is 6, so therefore c would be half of that. So now let's go ahead and do c squared is equal to a squared minus b squared. Move the 16 over, gives you a squared is 25, so a would have to be 5. So therefore, this would be, we haven't found it yet, is it horizontal or vertical? Okay, my foci. My foci are going to be on my major axis. The foci are at 11, 0 and 5, 0. Those are horizontal of each other. So therefore, since they're on the major axis, this is going to be a horizontal ellipse. So therefore, my larger number goes under my x. My larger number is going to be, since a is 5, I'm going to put a squared under x. I'm putting b squared, which is 16, under y. Number 13. My major axis has a length of 18, so that means that a is 9. My c value, I'm going to go ahead and pull both of these. You can always find your c value by this plus and minus statement. So my c is going to be the square root of 77. That's the distance from the center, which is going to be -9, to each endpoint. Now here's the tricky part. Let's use this focus to find the center. Add your x's, 1 plus 1, that's going to be 2, and divide by 2. Now this is horrible, right? How are we going to add these two y values? Well, it's actually pretty easy. If you think about -9 plus the square root of 77, and you add that to -9 minus the square root of 77, these actually just cancel. And leaves you with -18 divided by 2, which is going to end up being this -9 value again. So my center is located at 1, -9. So let's go ahead and use that. It's going to be x minus 1 squared. That's going to be a y plus 9 squared. And then the equals 1. Okay, is it horizontal or is it vertical? Okay, where is this point located? This is going to be on the major axis. 1, -9 plus root 77 and -9 minus root 77. These y values are above and below each other. So therefore, they're vertical of each other. The foci is on your major axis, so since the foci are located on a vertical axis, this will be a vertical ellipse. So your larger value goes under the y. We know that c squared is equal to a squared minus b squared. So that tells me that b squared is 4, so b would have to be 2. Again, since it's vertical, the larger number goes under the y, so a squared goes under y, b squared goes under x. Number 14, you have vertices at 7, -2, and -7, -2, and those are going to be horizontal of each other. So therefore, this will be a horizontal, since that's your vertices, that's on your major axis. This will have a horizontal major axis. And this one's kind of different. It gives you an eccentricity here. Now, I want to remind you that eccentricity is equal to C over A. Now, does that mean C is the square root of 33 and A is 7? No, because this could be a reduced ratio, so we got to be a little bit careful. So we're given vertices, so we can use vertices to find that A. The distance from here to here is 14. So therefore, my A value is actually 7. It does work out. So therefore, that kind of tells me that my C value has to be then root 33. So my A value is 7, which again matches up with a C value of root 33. And we can use the fact that C squared equals A squared minus B squared to find my B. So that's going to be 33 is equal to 49 minus B squared. B squared is 16, so my B value is 4. So let's see. Let's now find our center. We haven't done that yet. So there's our A, B's, and C's. The center, we're going to add on our vertices, add your X's, divide by 2. Add your Y's, divide by 2. So my center is located at 0, -2. So therefore, my equation is going to be x squared. We didn't have to translate it any. Y plus 2 squared equals 1. The larger number, since it's a horizontal ellipse, the larger number goes under the x. So a squared goes under x, b squared goes under y. And the last one gives you a foci. So let's use that to go ahead and find the center. The center of our ellipse, add your x's, divide by 2. Add your y's, divide by 2. So the center is going to be located at 4, 2. So we could go ahead and say that my equation is going to be x minus 4 squared over something, and a y minus 2 squared over something equals 1. Now let's find our A, B, and C values. So since we're given the foci, the distance from here to here is 8. That's the distance between the two foci. The C value will be half of that distance. But we got, let's see, our eccentricity is equal to C over A. And it actually, I wish it hadn't done this, but it gives you the C value again. I'd much rather them made you solve for this, because if the eccentricity is 4 over 5 and the C value is 4, if it hadn't been the same, you would have had to set up like a little proportion there and done 5 times 4 divided by 4, and that would have gave you your A value. But you can see that it matches up perfectly again, and your A value is going to be 5. Once you do C squared equals A squared minus B squared, that's going to tell you that you're going to have a B squared or a B value of 3. And then the last thing to determine is this a horizontal or is this a vertical? Okay, the foci are at 4, 6, and 4, -2. Those are vertical of each other. Those are above and below each other. The foci is on the major axis, so therefore, since it has a vertical major axis, this is a vertical ellipse. Larger A value is going to be under the y's. So therefore, A squared is under y, B squared is under x. There is your ellipse.